Good afternoon, everybody. Welcome to the first Future City seminar for this calendar year. I am privileged to have Professor Chris Hendrickson here with us to make this presentation. Professor Hendrickson is the Hammerschlag University Professor Emeritus from Carnegie Mellon University. He is currently the Director of Traffic 21 Institute. He is also a member of National Academy of Engineering, and he serves as the Editor-in-Chief of ASCE Transportation Engineering Systems Part A Journal. His research, teaching and consulting are in the general area of engineering planning and management, including design for the environment, system performance, construction project management, finance and computer applications. He was a member of the study panel for NASEM Future for the Interstate study. Again, without any delay, I'll let Professor Hendrickson start his presentation. Thank you.
Well, good afternoon. I'd like it to be relatively informal. We're a small group, so if you have questions as I'm going along, go ahead and wave your arm and I'll try and stop and answer them. I'll also try and allow a little bit of time at the end of the hour in order to answer questions. So tell me as we're going along. So the impetus or the incentive for me to talk about this topic came from the National Research Council study that was just referred to. And this is a study that was requested by Congress in the Fixing America's Surface Transportation Act of 2015. They asked the Transportation Research Board to conduct a study on actions needed to upgrade and restore the Dwight D. Eisenhower National System of Interstate and Defense Highways to its role as a premier system that meets the growing and shifting demands of the 21st century. How many of you are familiar with the interstate highways? Okay, I was hoping that it would be about 100%. So, you're familiar with the system. This is what's called a consensus study. It's a panel group. We met for a couple of years. We heard lots of testimony, and we did quite a bit of actual modeling work on the side. So it was a fairly extensive study. The report appeared in December of 2018. For those of you who haven't looked at these kind of studies, it's available for free digital download from the National Academy's press site, or there's a special site for the Interstate study that you can find by Googling it. So you can download all 700 pages if you'd like of the whole study. What I'm going to do today is kind of give you some of the high points of the study, but I'm also going to give you some of my own thoughts, particularly on the past of the study. So that's the plan, is to kind of give you a little bit of an outline for the history of the interstates and then talk about those study recommendations, which are right now being mulled over by Congress, and we hope that Congress will actually move forward on an infrastructure bill or a roadway reauthorization bill like the FAST Act over the next year or so. So that's kind of the background of this whole study. Post-World War II roadways in the United States. It's interesting history. This roadway started kind of in the first part of the 20th century for motor vehicles. By the time World War II came along, the federal-state partnership had been long established. The states built the roads, and the federal agencies, the Bureau of Public Roads, and then subsequently the Federal Highway Administration, approved the plans for the roads, provided some funding, and produced standards for what a roadway should be. At this time, there were both federal and state gasoline tax in place, and there were also a whole series of toll roads around the country, not so much in Florida at that time, but certainly the Pennsylvania Turnpike and the New York Turnpike were prominent examples of toll roads. This, by the way, was the first toll road through Pennsylvania. It was the national road that kind of cut across the southwest from Cumberland, Maryland, out to Wheeling, West Virginia. And so that still exists as a regular national road. The Interstate Highways vision that was kind of developed in this post-World War II period, controlled access, divided between the two opposing streams, and the normal assumption is that the interstates would be untolled. There were some interstates that were grandfathered into the system that retained tolls. The Pennsylvania Turnpike is a good example of something like that. Non-political, the idea was that the feds and the state Department of Transportation, the federal agencies, would decide where they were going to be, what the standards would be, relying on technical criteria. Both urban and rural implementation, and so as part of a smart cities, future cities, the interstates are of course very important for urban transportation. And in many cases, the urban expressways were linked to urban renewal, so you saw quite a bit of urban development that occurred once an interstate was put in place. And this is just an early example of a interstate type highway, the Willow Run Expressway that became Interstate 94, so that's kind of how it looked way back when. Interstates really got their kickoff in 1956 with the Federal Aid Highway Act. That authorized 41,000 miles of interstate and defense roads. Part of the justification, well, a major part of the justification was for defense purposes, to move troops and supplies around the country in order to respond to threats. The formula for construction was 90% federal, 10% state. $25 billion was authorized for a 12-year construction period. We still haven't finished the interstate system, so it's stretched on beyond 1956. And there were new taxes put in place, and the Highway Trust Fund was established, where the motor vehicle fuel taxes and tire taxes and those sorts of things all went into the Highway Trust Fund, and that was used for paying for transportation. Very important funding mechanism in the early days. And you can see the group that was involved in the study for the interstates, a bunch of old white men, you know. Things have become more diverse since then, which is good. I like to point out that the interstate highway actually had some technological development associated with it. I think the most prominent example is the Asho road test. And this was really interesting. There's this nice Calvin and Hobbes cartoon where Calvin comes to his dad and says, how do they decide what's the weight limit for bridges? And the dad says, well, what they do is they build a bridge and then they run progressively heavier trucks over the bridge until it breaks. And that's the limit, and then they rebuild the bridge. Well, you know, they don't do that. It's all models and comparison and that sort of thing. But this is the study where they built a series of pavement, a series of bridges, and they went out and broke them. And the idea was to kind of get an idea of what was the best designs for pavements. And this is the study that came up with the equivalent standard axle loads, where trucks with heavier weights have higher equivalent standard axle loads and have more of a stress on pavements and bridges. And you can see the experimental design for asphalt and concrete pavements that was put in place. So there's the actual Asho test. Was out in Illinois, I think it was. It's now been covered over with a new interstate. I love the picture of the computing that they had available, vacuum tube-based computing back in the era of the Asho test. So here's the as-built interstate, 48,000, 49,000, depends on how you count. 3 transcontinental east-west routes, 7 north-south routes. You can see there's quite a bit of blue down here in Florida for you folks, and there's also interstate, even though it's not really interstate, it doesn't go between states, in Hawaii, Puerto Rico, and Alaska. So the 48,000 miles of interstates is only a small portion of all roadways. So you can see here the interstate system is 1% of the miles, 9% of the bridges, so a higher fraction of the bridges, and thousands of miles of pavement, thousands of bridges associated with the system. but still it's pretty small compared to, say, the national highway system, the federal aid highways, or systematically all roads. In contrast, if you look at the kind of the target over here on the left, 25% of vehicle miles of travel are occurring on the interstate system, even though it's only 1% of the mileage. So the interstate highway system gets very heavily used, both in urban segments and in rural segments. This is an example of freight use that was presented to us by the Texas DOT for the study panel. And I thought it's a really good example of how important the interstates are for freight movements. So this is on trucks that have crossed over Laredo on the Mexican border and where they are after one day. And you can see they're just kind of spreading out from that southern entrance into the interstate highway network. And I just picked 2 days. Day 5, you can see they've gone all over the country. Okay, that's the sort of continuity and connectedness that the interstate highway system provides for freight movements in the United States. And it's something really exceptional. I mean, we all kind of take it for granted that that sort of thing will happen. You know, you order from Amazon, and you expect something there in the next day or the next 2 days. Well, it's largely because of this network of roadways that type of freight interconnectivity is possible. So, consequences of this whole mammoth construction project of thousands of miles of roadway. By some measures, you could argue it's the largest public works project in our history. Has large long-term economic and spatial impacts, both in terms of freight movements, but also kind of where people live, where new developments occur. You can know that because if you go to some of the towns that got bypassed by interstate routes, they tended to wither away, whereas the ones on the interstates tended to grow. Recurring and increasing congestion. Certainly in Pittsburgh, I'm aware that the interstates that are coming through the urban area in particular are increasingly congested in peak periods and in even off-peak periods, and certainly the Pennsylvania Turnpike, which I was mentioning, is continually congested. Lower crash rate than other roads. That's one of the good things about the interstate and the standards that the interstate was built to. Freeway revolt in many areas. San Francisco, other cities started resisting the development of new interstates in the urban areas because of the sorts of neighborhood repercussions of putting an interstate through an urban area. And there were a whole series of new processes and roles that developed as the interstates were built and put in place. Environmental impact statements came along so that the state DOTs had to consider what was the environmental impact of, say, putting an interstate through forest lands or the like. The public hearings put in place. When the first interstates were put down, there weren't a lot of public hearings. And there was more of a move away from technical criteria towards political decision making. Yeah, there are seats up here if you want to come up. No problem. I mentioned the sort of disruption that might occur with interstate developments. Here's an example. This is Miami. You're from Miami, right? Miami Overton. So this is the neighborhood before and after Interstate 95 and Interstate 395 came in, and you can just see the sorts of disruption that would occur from putting these roadways and major interchanges into an urban area. And Miami is only one of a whole series of examples where this occurred throughout the United States. Some of the reaction to that disruption is interesting. Some urban areas moved to bury segments of the interstate into tunnels. The most prominent example of that is the Boston Big Dig, where an elevated urban interstate was switched over to tunnels, and the tunnels extended the interstate so that there was more capacity. The old elevated structure was torn down and replaced essentially by a green swath of parkland through Boston. Very, very expensive proposition, as you might imagine, to do that kind of thing. In Pittsburgh, we have an interstate that runs north and south just to the east of our downtown. We received funding recently to try and cover that over with a lid and parkland on top of the lid. Seattle, by the way, is another city that's gone to that sort of a cover in order to try and re-establish ties between different areas of the urban segment. Some cities have abandoned the interstates. San Francisco is a prominent example where they had an interstate on an elevated structure and they just said, we're going to stop it. So construction was stopped, and then subsequently the interstate that existed so far was just torn down and turned over to arterials. So in urban areas, I think going forward it's going to be very, very difficult to try and put in more interstates. And in fact, we might see more of this sort of covering them up, burying them, or even tearing them down. So here's the growth rates. The blue is vehicle miles traveled. The red is population. The horizontal axis goes from 1900 up to 2015. And you can see that over the course of the 20th century, population has increased considerably, but vehicle miles of travel has increased even faster. And of course, the early days down there were really the first introduction of the internal combustion engine and motor vehicles. So you're seeing the growth of that technology and use of that technology over time. By the way, this is such an exceptional era right in here associated with the recession. It's the only period in my lifetime where vehicle miles of traveled in the United States had a dip. And it was largely due to the recession and the consequent per capita travel is not changing as much as total VMT. VMT is in the blue line here, and this goes from 92 to 2017. Per capita, per person travel kind of leveled out in 2006 and really hasn't gotten back to the peak travel that we saw back in 2006. Your bet is as good as mine about what will happen in the future, whether it's going to start going up again or whether it kind of levels off. When you're starting to think about the future of the interstate, which is what our panel was supposed to think about, that's a very important issue about whether per capita travel is going to go up or go down. We think that VMT total is going to keep going up a little bit because of the increase in population, but per capita travel is a question mark. I mentioned congestion. This is the recurring congestion in 2007 on the top graph, and you can see that you're starting to see more and more of these highly congested interstate highway segments. You can see Florida, Miami has some recurring congestion even back in 2007. Northeast and of course California had quite a bit. If the expectation for vehicle miles traveled that Federal Highway Administration has put forward continues, the sort of forecast congestion in 2040 is the bottom graph on the right. And so you can see a huge amount of red showing up basically all through the eastern part of the United States and the far west. It's only kind of the less dense areas in the Midwest and the Rockies that don't have a large amount of congestion. This is based on a projection of what VMT will be and essentially what sort of investment in new capacity and modernization is going to be. This is the scenario that we were charged to look at and say, what might we do about this in order not to incur this huge amount of cost associated with congestion and other things. Another thing that's going on at the same time is climate change. When the interstates were put in place, there was not a lot of attention to resiliency. There was not a lot of attention to sea level rise, not a lot of attention to the sorts of flooding effects associated with things like Hurricane Harvey that you see here. And so a number of the interstates require investments to try and make them more resilient and more resistance to this sort of disaster. This is a time where you can stop and ask questions. Stop, and I'll take questions. Yeah?
So Chris, you talked about new interstates, and you talked about the network is not completed. I'd like to hear from you about the legal and political ramification of adding toll roads on an existing interstate or trying to charge people.
Give me 20 minutes and I'll get to that. Okay? That's a whole funding issue.
Yeah.
So is there any modeling with other type of transportation built into this, so it's not just all roads doing capacity?
No, you got to think about kind of a split between rail and trucking. That's a very competitive balance right now. One of the issues, though, is that some of the rail networks are getting pretty congested. And so it isn't the fact that just because there's this congestion going on with trucking, then we can just move everything over to rail. There's congestion on the rail, too. So I don't think you're going to be able to have that sort of a big modal split. Inland waterways is another option, of course, and there you're limited by where the waterways actually exist.
Chris, you made it referring to this later on, but you brought a very important point about what was happening earlier on in building interstates, where interstates were being built right in the middle of urban areas.
Right.
And then the engineers had no say. No, the engineers had all the say. They do what they wanted to do.
Yeah.
But things are changing now. It seems that rather than the engineers having the say, it's the local people, the environmental people, and there's restriction of building, even when engineers see that it's logical, it's good, there's fights. How did you take that in consideration in looking at the future of interstates?
Well, the panel has some thoughts on that, and essentially, one of the things that we were advocating was managing demand in order to avoid having needs for capacity increases in urban areas, and I think that's the only way forward in that scenario. So I talked about congestion, I talked about resiliency. The other thing that's going on is that the federal government has been tracking an investment backlog for the interstate highway system over the last 20 years or so. It's a persistent and growing backlog of deficiencies. The deficiencies that are put in here are pavements, so trying to improve the pavements to the desired quality level. Capacity expansions, where capacity expansion is justifiable. Bridges, we have a number of bridges that are nearing the end of their lifetime and are becoming functionally deficient. So the Federal Highway Administration at this point in time figures that there's a backlog of investment that is justifiable of something like $150 billion. Just to put that in perspective, we're spending something like $25 billion right now. So there's this backlog to bring up the system to the desired, originally planned level of performance, quality. And there are also challenges for modernization, changing over intersections to be safer and more efficient. I can tell you in Pittsburgh we have some interstates that predate the standards for the interstate system, And some of those interchanges are pretty bad and need work. Facilitating technology development and implementation, lots of new technologies available for doing things, managing and adapting to climate change. All of these are challenges. And of course, as someone was pointing out, there's a problem with the funding sources for a lot of these needs. This is the federal motor fuel tax revenues adjusted for National Highway Construction Cost Index from 2003 to 2016. And you look at that and you say, what's going on? Aren't we having VMT going up? Well, two things are going on. First thing is the federal motor vehicle tax is denominated just in cents. So as inflation goes up, the value of the revenues associated with the motor tax fuel revenues goes down. The other thing that's going on are people are driving more fuel efficient vehicles. So those of you who are driving a Prius, you're getting great traffic mileage, but it means you're paying less in motor fuel tax per mile of travel. So you get this declining sort of revenue for the federal government. So just my summary slide on challenges where we're sitting right now, all of us. Demand exceeding capacity in a lot of areas, resulting in congestion. Worn out or wearing out segments in bridges. Unprepared for resiliency in many cases, particularly the interstates that are close to coastal areas and subject to flooding. Shortfalls in funding. I haven't talked much about technology uncertainty, but that is certainly a major issue. What is going to happen with connected and automated vehicles in the interstates? Climate change, and there's this demand from a lot of areas that are growing for more geographic coverage. Essentially the interstate miles, in terms of centerline miles, has been flat for a long time. Whereas a number of areas are growing quite a bit and are kind of starting to beat the drums for support for increasing the miles of interstate. So that's all by way of introduction to our study. So this is the study on renewing the national commitment to the interstate highway system, a foundation for the future. Now the name when I got recruited to the study panel was the future of the interstate. And we quickly started saying to ourselves, well, the future of the interstate might be all sorts of things. What we should really focus on are what are the policy recommendations we should make. And our major policy recommendation is in the title. And that is, we had this major commitment on the part of the federal government to the interstate highway system back in 1956. Over time, that kind of commitment and support for the system has dissipated. And so we think it's a good time for us to renew that commitment for federal leadership and make this system a premier system that will support the freight and user travel needs going forward into the future. By the way, it's a consensus study report, which meant that we've got a bunch of people. I have a list of the people who are on the study panel that all had to buy into these recommendations. And I was, of course, one of the members of the study panel. So, what did we do? We met with a whole bunch of people. We had meetings in all the places with yellow dots up there. Miami was one of them. We commissioned papers, and if anybody's interested, there are very nice state-of-the-art review papers on demographics, economic projections, travel demand, climate change, connected and automated vehicles. As I said at the beginning, those are all available for free online. We did some modeling, but we quickly concluded that the sort of standard models that were available from the federal government that they were using were inadequate for the things that we wanted to look at, and so we supplemented the models that existed with case studies, and we're still fairly critical of the models and suggest some improvements that might be made in models going forward. That was kind of our general approach. As I said, it took us several years to do this. I've kind of already said a lot of this. There are no modeling tools currently available that are able to fully capture the alternatives available to enhance the capacity or manage the system. In particular, reconstruction from the ground up wasn't included in the standard models. They were basically a pavement-oriented model. Whereas most states, I don't know about Florida, I don't know even local enough, but certainly in Pennsylvania, the old interstates like the Pennsylvania Turnpike are being rebuilt from the foundation up because it's so expensive just to keep repaving over foundation that is bad. And so Michigan, New York, Pennsylvania are all having to rebuild the interstate pavements after 50, 60 years of use. Model policy, capacity, or management changes at the national network level. Model responses to prices or other system management tools. There's no national demand-supply equilibrium model that you can just apply to this problem that existed. And we didn't have time in 2 years to develop one. And so we had to rely on kind of projections of different percentage increases of travel volumes as we went ahead. And the tools that we did use, Highway Economic Requirement System, the National Bridge Investment Analysis System, and the Pavement Health Track. Any of you use these models? No? Okay. I won't go into any of the details of them then. So, findings. Current level of spending is not sufficient. We're in $20 to $25 billion. I think I gave you that figure before. That's the current funding year for different things. We figure that what's needed to really improve the system and reinvest in the system is something on the order of 45 to 70 billion. And that's a big range, but it's a major increase, of course, from what's being spent today. And it may even be an underestimate. I mean, I mentioned that in 1956 they made an estimate of how much the interstate highway system would cost, and it was very low compared to the actual cost that existed. And this could well be the same sort of situation, but at least it'll get us going in the right direction and reinvesting in the system to move forward. And you can see that pavements, bridge rehabilitation, capacity additions, and operations are all part of the mix. Yes?
Does that include studies in engineering?
Yes.
So when you say reconstruction, that includes like...
Yeah, all the planning that goes
Okay.
on, that type of thing. And that, of course, is a small part of it compared to everything else. Blueprint for action, 10 recommendations that included program actions, including changes to federal legislation. So we made recommendations for that. Funding, which you asked about, and I'll have a couple of slides about. Standards needs, particularly for connectivity and automation. Data and modeling needs, I already talked about some of the critiques we had of the existing modeling systems that existed. And as I said before with the title, that we think that the key here is federal leadership. We need federal leadership in order to make this system really a premier system and allow for the needs that we have as a traveling public. First bullet is essentially coming back to that point about federal leadership. Another thing that the committee recognized is we have to move away from gas tax revenue. It could be a stopgap for another number of years, but we need to go to vehicle miles traveled tax, tolls for particular facilities, General revenues, by the way, is what's been being used to top up the highway trust fund lately, and that is, of course, a possibility going forward. System additions in congested or growing regions. How many more lanes can you actually squeeze into the right-of-way? Not that many. And certainly there are growing regions in the outskirts of metropolitan areas. Improved resiliency, provisions for connected and automated vehicles. Okay, you asked about funding alternatives. Gasoline and excise taxes, they're very efficient to collect. They have a historical basis. They're politically difficult to increase. Anybody know when the last time the federal gasoline tax was increased? About 25 years ago. Okay. Equity issues. I have a slide, I think, on equity issues in just a moment. On tolls, there are limited exemptions that already exist. Essentially, if you add capacity, lane miles, and have managed lanes, you can put a toll on and put it in place. But existing interstates are not allowed to have tolls. And I can tell you that's a problem in a state like Pennsylvania, where we have east-west routes and north-south routes that run parallel to the Pennsylvania Turnpike that are untolled. Pennsylvania Turnpike has been increasing the tolls on an annual basis for years, and now they've reached the point where they can't get any more revenue. They increase the tolls and they're going to divert traffic. And so Pennsylvania, despite some local opposition along Interstate 80 and that sort of thing, would like to put tolls onto other segments because of its geography. Banned from doing that. The committee made a recommendation to stop that ban, let local jurisdictions impose tolls if they so desire. VMT tax, technology is under development. I think compliance issues are going to be an issue. How secure do you get the VMT measurements? How much cost is associated with getting those secure measurements? That's going to be the issue there. And of course, general revenue and borrowing is an option. This is just a background on the federal trust fund. You can see it was projected to run out of money in 2015. It's been propped up by general revenue transfers. And I said I'd do a slide on equity. So this is the federal fuel tax revenue for different types of vehicles, and this is using the EPA fuel economy figures for different vehicles. And over on the left is a 2012 Ford 150, and it's up at 1.4, and then a little over 60% of that is a 2018 Ford F-150, good for Ford. They've made it more fuel efficient as time has gone on. Anybody drive a Prius in the room? Nope. Okay. 2012 Prius and a 2018 Prius are about the same. Toyota hasn't seen a big improvement in the fuel efficiency over the last 6 years. Tesla's on the far right. Anybody a Tesla driver? It's at 0. No federal fuel tax on a Tesla because, of course, it's charged off the grid with and charges a battery. So that's equity issues. I mean, if I'm a Ford F-150 driver and I look at something like this, I say to myself, those liberals in their Tesla, rich liberals in their Tesla, what are they getting away with? You were the one who asked about tolls. Well, here's an example. I love this. This is one of the routes in Virginia near Washington, D.C. This was a picture that appeared in the paper because the toll for one segment went up to $30. And of course the tolls are set by an algorithm based on what is the congestion level on the managed lanes, and as the congestion level on the managed lanes goes up, they have the toll go up. As congestion goes down, the toll goes down. That's how these management systems have been installed. And so this was kind of the peak that I can ever remember it hitting on this example. So,
So legally then, they can keep the same number of lanes on the system, the initial interstate system, and then take right of way to add on. Okay.
That's
That's
exactly
the
right.
case here in Florida. We have
yeah, and they have to get
95 and I-4.
right. They have to get approval from the Federal
the
Highway
federal
Administration for that, but the Federal Highway Administration has been granting those
Nobody
permissions.
has been denied yet. They
Yeah.
were all granted them as long as they maintain the initial capacity.
Yep. And some of these managed lanes, by the way, have provisions for if high occupancy vehicles get a freebie. So that's a local decision about what to do with those tolls. The other thing that's going on with tolls, which is very interesting, is that say 20 years ago, for the Pennsylvania Turnpike, 25% of the revenue coming into the Pennsylvania Turnpike went for toll collection. And that's because it was entirely a manual system at the time, and so they were paying for a lot of people sitting in toll booths around the Commonwealth of Pennsylvania to collect tolls. That number has been dropping steadily with the introduction of things like EasyPass, RFID tolling systems, so that now the Pennsylvania Turnpike has put in place a 15% reduction in tolls for anybody using the RFID tags. So they're kind of sharing the savings between the Turnpike Authority and individual motorists. And so we're seeing some technology improvements in tolling that I think makes it more attractive going forward.
So if I can build on this discussion, because I-4, I'm not sure if you're familiar with what's happening on I-4. So it kind of touched on many things that you mentioned, is because I-4 became so bad, old design, bad pavement, etc., that DOT decided to redo I-4 in the Central Florida area, starting with the central area, the city of Orlando area.
That's down to the foundation?
That's totally rebuilding it. The bridges,
So
everything.
you folks are doing the same thing that I've been seeing elsewhere.
Yeah, and it builds on what you mentioned. It is sometimes more efficient just to redo the pavement and everything rather than keep patching it. But the cost was estimated at 2.3 billion for the central part of I-4, about 20 miles. So they decided to do with the PPP project. So they brought a funding agency, Skanska in this case, to build it and use it to collect tolls on the managed lanes. So it's going to still be a combination of free and managed. The managed will be better designed than I-95 because of the weaving that happens because of adding a managed lane. And then they're going to collect, I think, for 40 years tolls. So Skanska will operate and benefit from the tolls and then turn it to DOT. So this is a combination of funding styles in this particular project. Yeah.
Right. And that's got a couple of unusual factors coming into it. One is that it's got the sort of traffic volumes that will permit raising the revenues that you need for the whole total construction cost. Not all segments of the interstate are in that situation. And secondly, you got sufficient right-of-way to add in those managed lanes. And again, not all of the interstates are that way.
Chris, my problem is that it seems that the managed policies that have been used over the past years, you took 270, or is it 270 or 275 from 66 to the there was a PPT program where this road was only 4 lanes, 2 lanes on each one. It has been extended, but the demand is still increasing, and the congestion seems worse now, even with that managed thing. So I just wonder whether there's something else out of the box that we should be thinking of, rather than the general methods we've been using for managing.
Yeah. Yeah. Well, I can give you my thought that particularly for interstate travel, 10, 20 years from now, it's probably going to be primarily autonomous vehicles. So drive them at night, something like that.
Well, along the same line, Elon Musk 2 days ago announced that he's going to sell a Tesla that hovers, like Back to the Future thing. So maybe that will not have a wear and tear on the table. Right? I don't think the models look into that.
Right. Okay, I got 5 minutes left, and I can say a couple of words about automated and connected vehicles because I just brought them up. The real incentive for a lot of automated vehicles and connected vehicles is improving safety, reducing crashes, something near and dear to a lot of the hearts of you folks here. The other incentive, of course, is to save driver costs. Interstate connectivity is a really interesting question right now. Is it going to be private or is it going to be public? I kind of lean towards having it private and using the telecom companies, but it's an open question. And it's also an open question about which communication technology is going to prevail. And we didn't, as a committee, weigh in on that sort of an issue because it's really quite uncertain. There are possibilities for doing narrower lanes with greater curvature, with good lane following automation, so that sort of thing. There may be a possibility for closer headways with vehicle platooning. By the way, the headways that I see on the interstates around Pennsylvania are a lot smaller than the ones that I learned about when I first started doing traffic engineering. So we have a lot of drivers out there that are doing manual platooning, and I think it'll be a lot safer with better technology where the brakes are tied together and that type of thing. So I'm all in favor of automating platooning. Reduction in traffic waves is certainly a possibility. Smoother merges with vehicle-to-vehicle communication. All of these are possibilities for improving the capacity of the interstate highway system with new technology. So I just said that. Potential for increases in roadway capacity. The extent to which we're going to be able to see that improvement is still, to my mind, in doubt. Because how you program the automated driving systems will influence what sort of capacity improvements you get. So, for example, the Carnegie Mellon vehicle, the Cadillac that we use for demonstrations and tests around the Commonwealth, is programmed to be very, very safe. Okay, so it goes along the interstate at 55 miles an hour and no faster. And all the vehicles just whip around it. Okay. It'll sit at a stop sign until it thinks that an acceptable gap occurs. And that acceptable gap for it is longer than the acceptable gap for you guys. Okay. It is programmed to be very safe. And you can see that the trade-offs associated with people who are designing these software systems are going to be between that sort of an approach versus an approach that gives faster driving, more efficient use of capacity, and that type of thing. So it'll be interesting to see how all of that plays out. Sensor software will not be perfect. Fog, rain, snow. You don't have snow. Don't worry about that. Long transition period with automation and manual driving conflicts. I'm very helpful, by the way, about particularly the new generation of partial automation systems that are appearing on vehicles. I'm a big proponent of the automated forward collision avoidance and the backward cameras and all that sort of thing. I think we're going to see some demonstrable improvements in crash reductions.
The cybersecurity is very important too.
Yes, yes. But it's important for anything.
Yes.
If you think your bank account is safe, you better. But I think you're absolutely right. I mean, there's a potential for havoc with a couple of tons of moving inertia.
It can be related to the sensor software because once you have this problem in the sensor, someone can take advantage.
Yep. And unfortunately, I do not believe there's going to be any complete fix to that problem. It's going to be a continual struggle to work with it.
The best team at CMU.
Yeah. No, we have groups of people working on this problem. Vehicle platooning, by the way, with automated systems has already been demonstrated in a number of places, Europe, North America, Australia. And so, it's also in regular use in Australia for mining. And so it's something I think is going to come. And it, you worry about the Uber drivers who are upset about automated driverless vehicles. But if you talk to trucking companies, they say that it's so difficult to keep drivers for long distance hauls. And a lot of the drivers really like doing deliveries and pickups around metropolitan areas and then turn it over, I think, to an automated vehicle to go between cities. And actually might be a win-win for everybody. I mentioned that interstates tend to be safer. Here's the breakdown of persons fatally injured in motor vehicle crashes. The interstate is fairly small. Other freeways, other principal arterials, minors, and on out. And of course, the interstate has 25% of the vehicle miles traveled. So you can see it's about twice as safe on that sort of a measure. Now, I'm running out of time, and I'm coming to the end. So this was our committee. It was chaired by Norm Augustine. It pulled from professionals from all over the country. We're in the process of doing briefings. And in fact, we have another round of those with the new Congress coming in. And as I said, I'm hoping that the new Congress takes the study seriously and thinks about what might happen in a new roadway authorization bill or more general interstate bill. This is my last slide. The top picture is a historic picture, and that was a test run of an Army transport across the country prior to the interstates. And it was a strain. General Eisenhower was one of the people who was on this caravan, and so he was decided at that time, I think, that something like the interstate highway system really made a lot of sense. And of course, there's the interstate that you all are familiar with. Okay, I told you I'd leave 10 minutes at the end, and I've left you 9 minutes. Yeah?
How much does construction play a role in congestion?
It plays a significant role. A lot of the projects, like the one about Interstate 4 that was being mentioned, there is a considerable amount of congestion that's associated with taking lanes out of service. And it's not only just for construction projects where you can put in place kind of permanent reroutings of one kind or another, but it's also the case for maintenance, where you have these moving maintenance zones that's going along. I'd have to look at the congestion figures to give you an actual fraction, but I would admit it is not negligible, and it's probably not the largest component. I think the largest component might be crashes, incidents, but it's certainly substantial. There is quite a bit of work going on accelerated construction, where you get bridges that are kind of put in place rather than constructed in situ. And I think the same sorts of things can be done with doing lanes and foundations and that type of thing, taking advantage of off-site construction and dumping it into place. So the DOTs vary in how much they kind of push to try and reduce those sorts of user costs at the cost of increasing the capital associated with the projects. And so that's a trade-off that exists when you're thinking about planning those things.
So is there an association between the length of the segment being constructed on and the amount of congestion, or is it just depend on the population density?
Well, that depends on the volumes, of course. If you've got volume coming on or going off, that's going to be one thing. And if you've got just throughput volume, then it really doesn't matter very much. and you just get a longer stretch where you're going at a slower speed to the work zone.
Right, I saw your chart, showing the United States, and saw lines going through Nebraska and over to Minnesota where it was heavily congested, and, from my experience, that's all due to construction, it's not due to actual cars on the road
Yeah.
or vehicles on the road.
Could be substantial amounts of it are coming from that kind of thing. Yeah.
Chris, so had the committee discussed also special cases like Florida and maybe New Orleans, where some model says that we could be underwater in 40 or 50 years? So,
No, we didn't.
we mentioned a little bit about that, banking.
Yeah,
and
no,
resilience.
all we do is we say that should be a consideration in doing designs going forward, and that existing roadways may have to be retrofitted. And we didn't go down into the level of talking about Florida or New Orleans, anything like that. Sorry. Different study. And when I said that I gave you this big range for how much money is required, part of that, or most of that, is from different assumptions about what the growth rate in traffic is going to be. But some of that is associated with decisions about how much money to put into those sorts of resiliency improvements. And that's a policy decision that has to be made. Yeah.
Actually, I have a question, like a little of from your perspective, how do you see the future of the mobility? Are you see very automated system, or kind of hybrid system, where human and the autonomous vehicles can play in the same ground?
Well, I think for the next 2040, we're going to be seeing a mixture. We're certainly not going to be seeing fully automated. You may see it in some niche locations. I mean, you can see it today. You go to the mine I was talking about in Australia, and basically all their trucks are all fully automated, and they're just running along. So you can see a fully automated thing happening. You can also see it on test tracks in various places. But in terms of the regular public roadways, I think we're going to be seeing a mixed stream of traffic for certainly my lifetime and maybe a good portion of your lifetime. The exception will be if we have some managed lanes that get dedicated to automated vehicles. And there you can see fully automated streams. And by the time, before that happens, we're going to have a lot of additional data about how fully automated vehicle streams behave. Yeah.
Did the committee consider uses for the interstate system beyond just moving vehicles? Could the interstate system be fused with, an updating of the power grid? So using the right of way to carry power from place to place, because it has a pretty comprehensive network of the country.
Yeah.
So
Nope.
any synergy between
No.
infrastructure projects like that, carry
Yeah.
power or data,
Yeah.
or
That might be another funding source. I mean, rent out the right-of-way. Certainly Pennsylvania has a couple of test programs going on right now and putting broadband on the right-of-way for roadways. And so that's I think a great use of roadway right-of-way for fiber optics. The power grid, I mean, there's safety issues associated with it, so you got to worry about that. I don't think a lot of people don't like running along the road with the high voltage wires above them. Other uses that, of course, have always been in place, rapid transit, and even hyperloop sorts of things are being talked about for roadway right-of-ways. So if I'm a DOT person who has control of right-of-ways, I'd be looking for any sort of opportunity along those lines that exist. I'm personally, by the way, a skeptic that solar panels and roadway surfaces is going to be a good economic investment over time. We'll see. There are certainly some proponents, but I'm skeptical. Yeah.
I have two questions about this kind of long-term investment project.
So as we know, long-term investment typically need to consider a lot of future uncertainties. And you mentioned a little bit like technology uncertainty. So the first question is, I'm wondering, during your discussion, the panel discussion, what kind of technology you specifically consider for the future highway system? I know automatic vehicle is of course one of them, but how about the others?
We had presentations on advanced materials that can be used. We had presentations on different types of interchange designs that might be used. We also had presentations associated with communications technology that might be used. We didn't make any firm recommendations along those lines, but it's certainly in the background documents. So if you're interested, go back and take a look.
And the second quick question. So instead of trying to meet the future demand, is there any discussion about trying to use this opportunity to try to guide the demand of the transportation? Right? I know the 1950s highway system kind of lay out the lifestyle of American people that use the vehicle for interstate travel.
Right.
How about use this opportunity to try to make another big influence? I'm not saying like take other people from the highway, but try to, for example, certain travel, certain origin and destination, we encourage them to use interstate. Mm-hmm. But for some other types, we try to switch them to other options.
Yeah. As I said earlier, one of the recommendations we had is to encourage management of the urban interstates in particular. And there's a whole range of things that can be done along those lines, including time of day regulations. So, for example, trucks might not be allowed in urban interstates in particular hours. There are tolls. There's public transportation investments that can be made. There's a whole discussion along those lines. And I think all of that is certainly fair game for anybody who's trying to manage an urban interstate, where particularly you're not going to be able to add a lot of lane miles. You can always think about going vertical or going underground for adding lane miles. Well, that would be expensive compared to the management tools that I was just talking about. Yeah.
I have one question. So did the committee also thought about that? Like you talk about the climate change in the design, but what is going to be like investing $140 billion onto the climate change? This is going to be induced demand on interstate, and what is another alternatives like high-speed rail for interstate?
Yeah, no, we didn't go into that level of detail. And in fact, we used a range of VMT forecasts for the future. The low end was something like 1%, high end was 3.5%. And so having high-speed rail would put you in that low end, and that would have implications for what sort of funding needs are going to be. So it's a trade-off. You can put in competing modes like high-speed rail and save some money on the roadway side, but the costs are there. Yeah.
As a committee, then are you hopeful that there will be a recommitment from the Congress? Or how do you see the future?
I've been when we released this report in December, I've come to the conclusion that the only media interest in infrastructure right at the moment is in walls on the border. And so I don't know what's going to go on. I mean, there's certainly been quite a bit of talk, and certainly interest among congressional staffers about an infrastructure bill of one kind or another. And the FAST Act, presumably, is going to have a reauthorization of some kind. Where the issues come up is when you start talking about funding. And increasing the gas tax, for example, I mean, Congress has balked at doing that for 25 years. And I thought that the sale of this idea of allowing local areas, states and metropolitan areas to have more flexibility in putting in tolls would be something that Congress might be able to buy into. And right now, we haven't seen that yet, but I'm still kind of hopeful that that's going to happen. And then it's not Congress imposing new fees, it's the locality. So we're kind of pushing the political burden onto somebody else. And I think a lot of localities would bite at that. Certainly places like San Francisco would be interested in that.
Just before we go, I know there's one important factor you've not said anything about. I'm wondering whether the committee looked into the socio-political factors engaged in this. For a simple thing, the willingness of the individual